Today I am going to discuss simple and multiple linear regression. Linear regression. Okay. I have provided R code. I ask you to solve this homework by using Python. Clear? You will use Python to solve the homework. Okay. Clear, right? Please, from next time, try to come to the class in on time. Okay. In that way, I do not need to repeat the materials again. So in last few weeks, I have covered 5-6 topics like basic computation, function, summation, integrations, data analysis, data mining, simulation, text mining, and wave analytics. Today, I am going to discuss about simple and multiple regressions. Okay, so all of you in this classroom know about these things. Okay, so could you please shut down your computer for the next few minutes, next 2 hours? Please shut down your computer. Try to understand what I'm doing. Chinidu, please shut down your computer. Shut down your computer. Complete off. Yeah, complete off. Please. I ask you and advise you not to open your computer, okay? Because the reason your final exam will be conceptual, right? I took one-to-one meeting with you, right? And then if you do not understand these things, you would not be able to answer those questions. And at the end, if you get 2, 3, B and C, if you have intention to pursue PhD, you would know. Are you understanding, right? I see 2 students telling me, well, professor, my all courses are doing like this, and these courses, if I get C, and how can I do the PhD admission, something like that. Clear? Okay. So all of you in this classroom know these are the linear equation: 2x plus 3y equal to 5, and then 3x plus 9y equal to 10, right? This is a linear equation, right? And there are 2 unknown and 2 equations. So we can solve it, right? There are 2 unknowns and 2 equations. So we can easily solve it. So there is a finite number of solutions, right? On the other hand, if you have a equation like this, 3x plus 7y plus 2z equal to 10, and 9x plus 3y minus 5z equal to 15. If this is the scenario, 2z, can you solve this equation? You can solve this, but infinitely many solutions, right? Because 3 unknown and 2 equations, right? In order to have a finite number of solutions, you have to have another equations, right? Okay. So this is what you understand from your high school algebra. Okay. So now if I ask you a question, I want to solve these things. I want to solve these things. 3x plus 5y equal to 10, 9x plus 11y equal to 20, 7x plus 9y equal to 13. And suppose I want to do the 10th equation is 10x plus 11y equal to 19. So suppose there is equation 1, 2, 3, and 10. Understand? How many equations in there? 10 equations. What I want to solve from there? X and Y, right? We want to solve X and Y, right? There are 10 equations. I want to use all of these informations to solve all of these 10 equations. I want to use to find the solution for X and Y. Okay? Is there any way I can solve it? I know Chinedu already know it because he took another class. Can anyone of you tell me how can I solve this? Are you understanding? Are you understanding? 10 equations is in there. I want to use all informations in order to get the solution for X and Y. I want to get the solution. I want a solution for X and Y by using all 10 equations. Understand? So this linear equations, all of this was introduced like more than 2000 years ago, 300, 400 BC by Euclid, geometry, and those are the people, they develop those things. So Archimedes, those are the things, they have developed the geometry, all of these things. So now in 1805, Galton give solutions for these problems. Okay. In 1805, Galton, Galton, Galton give solutions for this type of problem, which is known as the least square method. Least squares method. Okay. Least square method. So now we are going to discuss these things. So everyone in this classroom know this is the equation of what? This is the equation of what? This is the equation of what? Yi equal to beta 0 plus beta 1 xi. This is the equation of a straight line, right? Right? This is the equation of a straight line. In this equation, if you add an arrow term, yi equal to beta 0 plus beta 1 xi plus ei, if you add these things, then it will become a simple linear regression model. Simple regression model. Because of this E, it is known as the regression model. Understand? So E stands for what? E stands for error. E is for error. E stands for error, which is beyond human control. Which is beyond human control. Okay? Which is beyond human control, which we cannot observe. That means we do not have a numerical value for this error. Understand? Are you understanding? So in a production process, suppose you are a farmer and producing rice, right? How much crops are destroyed by the birds? How much crops are destroyed by the insect? You do not know that, right? So you cannot observe that thing. Understand? In other words, error terms are from populations. You can also write it. Error terms are from population which cannot be observed. This is from population which cannot be observed. Which cannot be observed, but can be estimated from sample. Okay? Once you have a sample, from the sample you can estimate it. Clear, right? Beyond human control error. If a company produces peanut butter, okay, and some of the peanuts will be destroyed because they will mixed up with the machineries, right? So the error term is with the entire production process, how much population. But when you estimate these things, so let me write another term. When you put here head, this is called the residual or estimate of error. Estimate of error. Okay? So now you understand what is error and what is residual. Residuals means from the sample, you feed the regression model. After feeding the regression model, you can estimate the error, which is known as the residual. Okay. So residual is the estimated error. You can also write it residual is the estimated error. Residual is the estimated error. Okay. So now for this equation, what is yi? Yi equal to response or dependent variable. Okay. Xi equal to what? Independent variable. Independent or predictor or explanatory variable, or simply called the regressors. Okay. Simply call the regressors. You have a conceptual final exam. The materials that I am teaching from now on up until the end of the semester, you will get 10 to 15, 20 conceptual questions. Okay. That is what you have to write 1 or 2 sentences for each questions. Okay. What is my beta zero? Beta zero is the intercept, or you can put it here starting point. I will discuss this more deeply. And beta 1 equal to what? Beta 1 is known as the slope. Okay. Beta 1 is known as the slope. Okay. So now linear regression said, right? Let me explain these things. Okay. Here I want to put here X, and here I want to put here Y. Okay. X and Y. I want to put here X and Y. So in this case, my starting point could be origin in here. Okay. My target is to reach in there. This is suppose 10th floor. Okay. This is suppose 10th floor. My starting, I want to reach in there. I could reach there from there. This is my starting point. My starting point could be in here. I could reach there. Okay. My starting point could be in there. It is. So this is the beta zero. This is the beta zero. Suppose this is equal to suppose 3. So my beta zero equal to 3. Beta 0 equal to 3. Suppose this is equal to 5. Then my beta 0 equal to 5. Clear? Are you understanding? Target is to reach in here, and beta 0 is the intercept or starting point from where I am going to start. Okay. Now what is slope? Slope means rate. Okay. That means how fast and how slow you can reach there. For example, if I want to draw another picture in here, target is to reach in there. This is my 10th floor. 10th floor. Okay. I can reach 10th floor in this format. I can reach 10th floor in a faster format. More faster, right? Are you understanding? So I can reach in here in this slower format, or faster like this. So this is called the slope or beta 1, or also known as the rate, or sometimes called the change of rate. Okay. Change of rate or slope, these are all used on the alternatively. Okay. These are the same thing. Okay. So you understand the difference between this is a equation of a straight line, when there is an error is added and some assumptions are put on that error and yi and xi, then it becomes model. Okay, let me tell you, this is known as the linear equation, and this is known as the model when error term is added with the linear equation, and on the top of that some assumptions are put on these and xi's. Okay, what are those assumptions? Now I am going to discuss those things. Clear? Okay. Assumptions. So distributional assumptions, distributional assumptions on EI and YI. Okay, distributional assumption. So you know the probability distribution, right? Binomial distribution, Poisson distribution, negative binomial distributions. So how many of you are taking Dr. Yevgeny's probability course? 510? You are taking it, right? You are taking that. So you know the probability distribution, right? Binomial, negative binomial, hypergeometric, and these are discrete probability distributions. There is also continuous probability distributions. One of the most useful continuous distribution is Gaussian distributions or normal distributions. Okay, so the Gaussian or normal distribution has a mathematical shape like this. Don't get scared, nothing is coming in your exam or homework from this mathematical form. Okay, so this distribution has a mean equal to mu. This distribution has a standard deviation equal to sigma. Okay, this x is a random variable which is taking value positive infinity to negative infinity. Okay, clear? So now I say distributional assumptions. So distributional assumption on what? On EI and YI. On these two terms, there is a distributional assumptions. Number one, EI is normally distributed with mean 0, variance sigma square. Clear? Variance sigma square. This is a assumption is taken over this. Okay. Number two, second assumption is yi is normally distributed with mean beta 0 plus beta xi. This is the mean and variance is the same. Okay, variance is the same, sigma square. Okay, so let me tell you what does that means. You have seen these things, this is called the normal probability curve, right? Right? In this case, it is mean, right? So mean could be 0 or mean could be non-zero any number. So what does standard deviation sigma means? This is how spread is. If this is like that, mean is same, but this is like very shrinked. This is a spread out, right? So how high variance? And in this case, variance is low, but the mean is same. Okay, are you understanding? So if you see a distribution, normal distribution like this, okay, so that means this is your mean, but that is variability variance. Okay, are you understanding? So both EI and YI has the same variance, sigma square. When you plot this and construct a histogram, from the histogram, if you add the top middle point of each bar, then if you take a look at the histogram or the smooth curve from the histogram, you will see both of the histogram has same type of spreadness. Okay, so that means EI and YI has these distributional assumptions we have. This is the two distributional assumptions. Okay. What are the model assumptions? This is the distributional assumption. Distributional assumption. Yes.
Can you repeat the distribution assumptions? Thinking what you like. The equation.
These?
Yes, like EI is how you state this up.
Okay. So if you want to write like this, EI, normal distribution, right? I'm writing it 1 over twice phi sigma e to the power minus 2 sigma square EI square, because mean equal to 0, right? This is. Now, if you want me to write that one, f of yi, then how can you write that? Because they have the same e to the power minus 2 sigma square yi minus beta 0 minus beta 1 xi square. See, this is the mean, right? That is the mean, right? Okay. This is the mean, right? This is the mean, right? That is the mean. Understand? Is this what you asking for? So then what is your question? I have to understand your question.
Is number one saying EI is normally distributed with
0 mean and variance sigma square.
that's not
Okay. EI is normally distributed with 0 mean and variance sigma square. YI is normally distributed with mean beta 0 plus beta 1 xi plus comma sigma square. Okay. Thank you for asking me questions. Now, model assumptions. What are the model assumptions? Model assumptions. Number one, model assumptions is YIs are independent and they are not serially correlated. Serially correlated. What do you mean by serially correlated? That means, you know, many time series data, if this girl has a business, she sells, suppose this, last year, she sold $1 million, okay? Previous year, she sold 800,000. Then previous year, she sold 700,000. So that means it is increasing, right? Serially correlated. So the main assumption is that YI must be independent and they must not be serially correlated. That means there is no dependency among YIs. If there is a dependency, then time series model, which I'm going to discuss, not in this class, in other class. Okay? Then time series model will be appropriate. Clear, right? This is the assumption number one. Assumption number two, constant variance. Constant variance, sigma square. Okay, variance is not changing with the changes of the data. Okay, for example, take a look at that. If I have in here xi and here I want to put here just the variance, if they look like this way, so these are the all values. Is xi changes, then this is changes, right? Okay, xi changes, this is changes. Xi changes, this is changes, but their changes is changing. Okay. Similarly, xi is changing. You found something like that. Other way, you can find like this. Xi is in here. It is like changing. Okay. So constant variance. So when xi is changing, are the yi values or residual errors, those values are changing. This is a constant. Okay. Number three, xi's and error term ei's are independent. Okay. Your upcoming homeworks will not be that difficult. You can do these things if you search through, browse through internet. But in your final exam, if you do not understand the basics, you will have trouble. Okay. I know all of you have a big dream. Some of you want to do PhD, and in that case, please put attention on this material. Okay. Let me see whether I have finished writing all the assumptions. I think so. Constant variance. Okay. So now, these are the all things. This is the three model assumptions, and these are the distributional assumptions and linear equations. When you add in these linear equations, when you add this error term, it become model. Now, suppose I have given data yi is my weight. Okay, xi is my height. Usually higher height, higher weight, right? So suppose yi and xi is given, suppose this is given 160 lb, this is 5 feet, this is 200 lb, this is 5.5 feet, it is 140 lb, this is 4.5 feet. X and y are given. Are you understanding? By using this x and y, I need to estimate beta 0 and beta 1. Are you understanding? Are you understanding? Remember, there are 10 equations, right? X and y is given. Sorry, these numbers is given. This 10 is given. This 10 is given. And then if you multiply these things, this is also like, this equation is also similar to like y, beta 0 plus beta 1, x1, xi. Okay. So now, this equation like that, I have to use all of these y's and these coefficients in order to estimate this beta 0 and beta 1. That means x and y. Are you understanding? Clear, right? So now height and weight is given. Height and weight is given. By using height and weight, this unknown, how can I compute? Okay. So why this is called linear model? Because linearity is determined by this slope. If someone asks you why this is called the linear model, you said that the model is linear because of beta 1. Beta 1 determines in linearity, how fast, how slow it is going up or going down. This model could be, in terms of figure, this model could be like this. Here x, here is y, height and weight. It could go like that way, or it could be supply and demand. Okay, supply is increasing, demand is decreasing. So it could be like that. This is linear, right? Understand? So like y equal to beta 0 plus beta 1 x I plus ei. If this is the model, this model could take this shape or that shape. Yeah.
So are you saying that if the slope takes another function like the linear function, the square, it stops being linear?
Okay, so he asked the question, can I take x equal to ln x? Yes, sometimes we can do that. I can do ln yi. Usually ln yi taken in order to make this yi normal.
I mean, like if if the line is attached to the slope, it's the beta 1.
You want to say log of beta 1?
Yeah, I'm asking.
Okay, so your question is beta 0 plus yi plus ln beta 1 xi plus ei. Is this still linear?
Yeah.
Is this your question? No, it is not linear. It is not linear. It is coming directly from linear equation, which was discovered 200 before Christ. 300 before Christ, if I remember correctly. When I search in online, I find that when linear equation was first developed. Because if I teach class and if I do not give some history how this come into an existence, then I cannot motivate my students, right? That's the reason anything I did, I want to find some history. Okay. Even if you put here square, it will no longer be the linear model. If you put a square root, it will no longer be, it lost its things, okay? So, a equation is said to be linear because its linearity is determined by the slope parameter. That means the coefficient of xi. Clear, right? Just remember these things. Okay. So now, how can I estimate yi equal to beta 0 plus beta 1 xi plus error ei? How can I estimate beta 0 and beta 1? This is what now I'm going to show you. You can write here ei equal to yi minus beta 0 minus beta 1 xi, right? Just taking one side to the other. Then you take the square on both sides. I take the square on both sides. Okay? Which is known as the, and then if you take the summation on both sides, then it is known as the sum of squares of error. Okay? This is known as the error sum of square. Are you understanding? This is what Galton proposed. He come up with this idea. Purpose is to minimize the error. Listen, in any production process, whether it is in the farmland or in the industry, okay, in any production process, when products are produced, some of the products are destroyed, right? Even the Chinese iPhone producing factory, they cannot produce all the phone smoothly, right? 1 or 2% of the phone destroyed when the manufacture takes place, right? Clear, right? Any production process, some of the product would have defect, okay? The purpose is to minimize that error, that product error as minimum as possible, okay? So we are taking the sum of square of error. This is the sum of square of error, right? We want to minimize this by using calculus, okay? By using differentiation. By now, if I write here as a short notation of E is the short notation, and differentiate it with respect to beta 0, then what we get? We got 2 sum and I goes 1 to yi minus beta 0 beta 1 xi, okay? And then if you again differentiate this, these 2 comes in here, again you differentiate this, then there is a 1 beta 0, right? Beta 0, if you differentiate, then it will be 1, right? So for example, ddx of 1 minus 2x cube, how can you differentiate this? This is your difference is 3, 1 minus twice x, and then 2, 3 minus 1 equal to 2, then ddx of negative 2x, right? If you differentiate this, that the same way I differentiated, I got this equation. Minus 2 sum of n, I goes 1 to like this, yi minus beta 0, beta 1, xi, like this. This is what I got. Now, second time, if I differentiate this with beta 1, if second time, if I differentiate this with beta 1, then what I am getting? 2 I goes 1 to n, yi, beta 0, beta 1, xi, and then if you differentiate these things, then you get their xi, which will give you minus 2 sum xi, yi, beta 0 beta 1 xi. This is what you are getting. Okay? This is what you are getting. Okay. So now, if you put here 0, in order to get the solutions, you will get the solution of beta 0 and beta 1. Let us put it here as equation 1, then put here equation 2. Okay? Equation 1 and equation 2. Now I can write from equation 1, we get -2 okay. So from there, if you multiply this sum of yi and then n beta 0 and beta 1 sum of xi equal to 0. So now here you can write here n y bar and beta 0, put here these things, and then put here beta 1 here and x bar equal to 0. So x bar equal to what? Sum of xi over n, right? Then sum of xi equal to what? Nx bar, right? Okay. From there, if someone asks me to compute beta 0 hat, what I get in there, I got y bar minus beta 1 hat x bar. This is what the estimate. Now take a look at that. I have x and y, right? I have x and y. From the x, I can find the average. From the y, I can find the average, right? So this minus that is giving us what? The estimate of beta 0, right? Clear? Right? So I have one result in here, but I have to find the beta 1, beta 1. Okay. So this is the one result. Now from equation 2, you remember the way I have written the equations? Y1 equal to beta 0 plus beta 1 x1 plus e1, y2 equal to beta 0 plus beta 2 x2 plus e2, and then goes all the way yn equal to beta 0 plus beta 2 xn plus en. You remember that, right? Suppose this is my weight equal to 200 pound, 160, 180. This is equal to this is weight, this is equal to height 5.5, 6.1, 9.2, something like this, right? So by using all of these things, my purpose is to get the estimate of beta 0, which is unique. We got these things. Now how can I get the beta 1? So I can get the beta 1 from second equation. From second equations, I have -2 sum of xi yi minus beta 0 beta 1 xi equal to 0. This is what I have from second equation. -2 sum of xi yi minus beta 0 minus beta xi equal to 0. This is what I have. Okay. In this case, let me multiply these things. We have sum of xi, yi, and then we have beta 0, sum of xi, then we have beta 1, sum of xi square equal to 0. Okay. Now, in this case, if I want to plug the value sum of xi, yi, I want to plug the value of beta 0, which is equal to y bar minus beta 1 x bar, and then this is sum of xi minus beta sum of xi square equal to 0. I plug this value. This value I plugged in there. Now what I have sum of xi, yi, and then this is y bar, beta 1 head x bar, and then here I can put here nx bar. Here is beta 1 head, sum of xi square equal to 0. Okay, so this is negative sign. Now I can write here xi, yi, and then I can write here nx bar, y bar, and then I can write here n beta beta 1 head and beta 1 head x bar square and beta 1 head sum of xi square equal to 0. Okay. Now I am very close. So if I take this type of initiative in here, I want to take minus beta 1 head as a common, then I have sum of xi square and then n x bar square. Then if I take minus common there, then I will have sum of xi, yi minus n x bar, y bar. This is what I have. From there, this cancelled out. Beta 1 hat equal to what? Sum of xi, yi minus n x bar, y bar. And then I can write here sum of xi square and x bar square. Are you seeing these things? Okay. So now these are the two solutions. This is my beta 0, which is equal to y bar minus beta 1 hat x bar. So these are the two solutions. Are you seeing these things? So when you run the regression, and if you get the output, and in the output you set the coefficient beta 0 and beta 1, this is the formula beta 0 and beta 1 is estimated. Okay? Clear now? So when in the regression Python or R, you just put the data and run the code and declare your dependent and independent variable, and at the end you got the output. This is the way they are estimating your variance. Question?
So like, what's that symbol that kind of looks like a Y on top of the box right there?
This one?
It's the one all the way at the top. You know, not the hat. It looks like a Y, but
This one?
no, it's the one on the top of the it's like it's right by the hat. No,
Yeah.
No, more to our left. Can I point it out to you?
Yeah. So this is the negative sign cancelled out.
Oh,
There are two negative signs cancelled out. Okay. Okay. Clear, right? Okay. So now let me draw something. Now this is the basic things you need to understand this. Suppose I have this graph in there. Okay? Graph in there. Suppose I want to put here x equal to height. And there I want to put here y equal to weight. Okay. So suppose I want to put here height equal to suppose 5 feet. Okay. Suppose 5 feet I do. If I fix a height and corresponding to a 5 feet height, there will be many people who have a different weight, right? Suppose he is 5 feet, I am 5 feet, she is 5 feet. Understand? His weight is 170 pounds, my weight is 200 pounds, her weight is 190 pounds. Understand? Are you understanding? So, in the regression model, xi are fixed. That means xi does not have any probability distribution. Are you understanding? Are you understanding? When you fix the height for a particular fixed height, okay, there is a weight distributions, right? So now if you want to construct a weight distributions in here, so histogram, it should be like this. In this case, there are 5 feet. There is a 5 feet weight equal to suppose 130 to 140. Okay, 140 to 150, 150 to 160, 160 to 170, 170 to 180, 80 to 90, 90 to 200, 200 to 210, 220, 230, 240, and 250. Suppose this is the things. Are you understanding? So now 130 to 140, that many people is in there, okay? So 140 to 150, that many people is in there. 150 to that many people is in there. There, that many people is in there. And then again you got, so I do not have a lot of space in there. Again, that many people is in there. That many people is in there. That many people is in there. So this is the histogram, right? Now, if you add the top middle point of each bar, this is the weight distributions. Okay. Now, if you add these things, are you seeing, are you getting normal curve? Are you getting normal curve? That has a mean equal to is in here. Okay. Now, if you take another heat 5.5, you will get another same kind of curve, right? That will have another normal distributions, mean is in here. If you take another heat 6 feet, then you will get another normal distributions is in there, right? So, and then if you add this, purpose is to, this is your line. You understand? Are you understanding? That is the rationale how linear regression model is constructed. So in the linear regression model, X is independent variable, X is explanatory variable, X is predictor, X is regressor, but X is fixed. X does not have a probability distributions. Are you understanding? Because once you fix X height, then there will be distributions for weight. Clear, right? That is the basic idea of linear regression. That is the basic idea of linear regressions, how linear regressions come into an existence. So if if it is asked to you in linear regression model, X has a distributions or not. If this is the question you are asked, you will immediately reply that X is a fixed, which does not have a distribution. Okay, corresponding to each X, Y has a distributions. This is the explanations that I gave. And the distributions are usually symmetric and non-symmetric, skewed to the right or skewed to the left, or symmetric. Okay. So another thing that I want to tell you, this is the mean, right? Mean, right? Mean, right? This is the mean, right? This is the mean. This is the mean of these distributions. This is the mean of these distributions. This is the mean of these distributions, right? So we are running a regression line, average regression line. So when you take the expected value of yi, this is the model, yi equal to beta 0 plus beta 1 xi plus ei. When you take this, you will get beta 0 plus beta 1 xi, and then expected value of ei, that is equal to 0. So that means you have expected value of this equal to just that. Okay. It is called average regressions, mean regressions. And another reason, if you take a look at the beta 0, this is average, right? Beta had average of y minus beta 1 times average of x, right? Average. Similarly, if you take a look at that one, this one, here is also, there are joint summations minus their joint mean. Here is square of the independent variable minus the square of their mean. So that means average is existing in there. And moreover, the idea of this is called, because this line is going through the average point. Okay, that is why it is called the mean regression or average regressions. Understand? So when you do this regression, the simple regressions, that is nothing. If you x in there and y in there, when this line is going through, for each x, this line going through the average of the y's. Okay, average of the y's. That is what I show you by using the graph. Okay, after doing this, now I want to show you one thing from R programming. Okay, let me go to the D2L. Okay, let me download it. Let me finish something then. In order to understand these things, I need to do something more. Okay, I downloaded these things. Now I will open it. Four, three, one, two. Okay. I open this, but okay. Good. I'll discuss these things. But before that, let me do something else. I want to find out how those standard deviations, all of these things are computed. Now let me going to show you some of those things. Okay, so once you get the estimates of beta 0 and beta 1 are the estimates of beta 0 and beta 1. So beta 0 hat and beta 1 hat are the estimates of this. Now the fitted regression line is yi hat equal to beta 0 hat plus beta 1 hat xi hat. So from the x and y, you estimated beta 0 and beta 1. Now this is your predicted or fitted regression line. Understand? In this fitted or predicted regression line, error term is not in there, right? Are you saying error term is not in there, right? Because by minimizing the error, I fitted this line. Okay? More specifically, if you want to write, you just plug the value of beta 0 in there and beta 1 in there, then it will be the fitted regression line. Now, how to compute residual? Take a look at that. Yi value are, I will get yi value when I will give xi value in there, right? So residual is what? Yi minus yi hat. This is called the residual or estimated error. Okay? So suppose I give you, you found beta 0 hat equal to 5, beta 1 hat equal to 7, and I give you xi, new xi equal to 2. Then you can easily find yi hat, right? You can easily find yi hat. So yi hat you find in there, and there is the original data, there is a yi hat, right? So the xi equal to 2 I gave corresponding to row number 17, suppose. Corresponding to row number 17, xi equal to 2, and then corresponding to row number 17, there is a yi value, right? This yi value and that value is called the estimated error. Okay? Are you understanding? Okay. Now I have to find some confidence interval. Okay. So I have shown you, this is what I had. Beta 1 hat has a formula, sum of xi yi minus n x bar y bar, and then there is a sum of xi square and n x bar square. This is the formula. These things could be written sum of xi minus x bar and sum of yi minus y bar, and these things could be written sum of xi minus x bar square. These things could be written like that. That things could be written like that. If you do not believe me, just multiply these things and do the simple calculations. You will end up with this. Understand? Are you understanding? If you do not believe me, if you are a great unbeliever of me, so just do the simple multiplication. Okay? Okay? That there is a reason for doing that. So because, can any one of you tell me what is the meaning of this xi minus x bar equal to what? Sum of xi minus x bar? Did someone say 0? This is mean deviation measured from mean. This is always 0. Okay? If you don't believe me, just multiply this sum of xi minus this times that equal to n x bar. Okay? So this times equal to what? N x bar minus n x bar. And x bar. This equal to 0. So x bar equal to what? Sum of xi over n. So now what I will do, I will multiply this sum of xi minus x bar yi minus sum of xi minus x bar y bar. Okay, this is fixed and this is 0. So that part is gone. So I have sum of xi minus x bar square. So how can I write this? Beta 1 hat could be written as sum of xi minus x bar yi and then sum of xi minus x bar square. Okay. So this is what, because this part equal to 0. So now if I want to take a variance over there, then what will happen? Variance of beta 1 v bar, that means variance of this whole quantity xi minus x bar yi divided by sum of xi minus x bar square. This is the whole quantity. But this part is a constant. Let me draw it with another color. This part is a constant. Remember, xi's are fixed, right? And yi has a variance, yi has variance sigma square, right? So now if that is true, then I have to take this sum of xi minus x bar square because if you take the variance of ax, so it will be a square variance of x. Okay, it is a square variance of x if you take the variance of x. And then if you want to take in here, it will be sum xi minus x bar square and variance of yi. So now what are you getting in there? Sum of xi minus x bar square times sigma square divided by sum of xi minus x bar square, like this. So this one cancel with another one. So you have a variance of that. There is a rationale why I am deriving this. So this is the variance of beta 1. This is the variance of beta 1. Now, variance of beta 0. Variance of beta 0 could be computed by variance of beta 0 could be computed by variance of y bar minus beta 1 hat x bar. So which you can write variance of y bar plus that is a variance of beta 1 hat and then plus x bar square. Okay, so now this is equal to sigma square over n plus, here I just found this variance equal to that, which I want to plug in there, x sigma square sum of xi minus x bar square, and here is x bar square. And then from there, if you try to take this out, this and x bar square sum of xi minus x bar square. That is the variance of beta 0. Why I find these things? Why I find these things? Remember, confidence interval. Confidence interval for beta 0 equal to beta 0 hat plus minus t 1 minus alpha over 2 and minus 2 degrees of freedom time standard deviation or standard error of beta 0. So which you can obtain by take the square root over variance of beta 0 hat. Okay. Now confidence interval for beta 1 hat, which is equal to beta 1 hat plus minus t 1 minus alpha over 2, that is the t distribution times standard error of beta 1 hat, which could be obtained just by taking square root of the variance of beta 1 hat. Understand? So when you write the code, run the code in Python and R, you got estimate of beta 0, beta 1, you got the confidence interval, right? Are you listening? So that is what computed by this approach. Now you can ask me, hey professor, how can I got sigma square, sigma square? The sample data x and y, height and weight, that is given. From there you can compute sample variances, right? That sample variances you will plug in there. Clear, right? Okay. Right? Okay. Now I want to show you something different. Let me run these things. Okay. I want to take 1 minute from your life. Please pay your attention and tell me the difference between this figure and that figure, this figure and that figure. This could be a question for your conception final exam. That is confidence interval, that is prediction interval, right? That is confidence interval, that is prediction interval, right? Okay. So which one is bigger? Prediction interval is wider, right? And confidence interval is not wider, right? And this is the fitted regression line, right? I fit the regression line. On the regression line, I construct the confidence interval and I construct the prediction interval. Why prediction interval is the bigger? Prediction interval is constructed for the new observations. Okay? New observations. When these things was done, this is for what is given. What is given? What is given from there? Okay? What is given from there? So theoretically, I want to show you how this is bigger than that one. Are you understanding? Theoretically, I'm going to show you how this one is bigger than that one. Theoretically, I'm going to show you how this one is bigger than that one. so that in your life, you will never forget why prediction interval is bigger than the confidence interval. That is theoretically proved also. Confidence interval for the data. Okay? Confidence interval, prediction interval for a new data outside of the given data. I'm predicting. Okay, so in your exam, if I ask you, tell me the difference between prediction interval and confidence interval for a linear regression. If someone said that both of them are same, then I will be mad and give that student 0, right? So in one class, I asked a student like, what is the difference between error and residual? One student wrote, there is no difference between them; they are the same. Okay, but when the individual meeting takes place, so I politely, very politely explain by giving her 5-10 minutes so that she, what mistakes he or she made with me, I do not want it to repeat it when he will be in the job or will be interviewed, right? Remember, they will ask you, what is the difference between residual and error? Simple. Residual is the estimated error. Human being, error is beyond human control. This is for the population. We cannot observe the error, but we can estimate the error. Okay. So you got it, right? I purposely constructed these things so that you can visualize this thing, and then you can see now the theory. Okay, let me take you to the theory. So our line was this one. This is our fitted line. yi hat equal to what? Yi hat equal to beta 0 hat and beta 1 hat xi. This is the fitted regression line, right? Fitted regression line. Okay. Now, if I want to take the variance of yi hat, what I get? Variance of beta 0 plus variance of beta 1 hat xi, and then I want to write here y bar minus beta 1 hat x bar plus beta 1 hat xi. Okay, which I can write variance of y bar, and then I can write here beta 1 hat xi minus x bar. Here I can write like that. From there I can write variance of y bar plus xi minus x bar square variance of beta 1. Okay. So this is what I can write here, sigma square over n. This is what I can write here, xi minus x bar square. And then this is what I can write, sigma square sum of xi minus x bar square. This is what I can write. If I take these things as a common, 1 minus, and then xi minus x bar square sum of xi minus x bar square. Okay. You have question? Any confusion? Anything? What? Okay. Oh, if you are okay, then there is a reason for laughing, right? Understand? Yeah. Okay. This is for fitted line. Okay, this is for fitted line. Okay, now standard deviation of yi hat equal to just taking the square root of variance of yi hat. Okay, this is what you use in order to compute your where is that one, the confidence interval one. So if you want to construct the confidence interval for that one, then it will be yi hat plus minus t 1 minus alpha over 2, then n minus 2, and then the standard deviations of yi hat. This is the confidence interval formula. This is what you got from there. This is okay. Plus minus. Are you saying plus minus some? This is the plus. This is the minus one. The shaded line bottom one, shaded line top one. Okay. That is the confidence interval formula. That is the confidence interval formula in there. Okay. Okay. Now, these things I ask you to write for the next few sentences. Listen, when you feed the regression model, you feed the regression model for the data, right? That data has a mean, right? But for the new observations, you do not know all the new observations, so you do not know the mean of the all new observations. Are you understanding? You understand the point? So I want you to predict, he taking new observations, but all of you got the same data, all of you got the same, feed the same model, okay? Same results is coming, but I ask you to predict. So when I ask you to predict, he take a new xi, she take a new xi, you take a new xi, and for these xi, there is a bunch of y, and for all of those y's, the mean I do not know. Because I am asking you make a point prediction, understand? I do not know the mean. I do not know the mean of the y. So that is why I'm going to write these things for you so that you can understand. For a new, write it. For a new x equal to x n plus 1. Okay? We have a new y n plus 1. We do not know the mean. We do not know the mean of y n plus 1 and only estimated it by confidence interval and only estimated it by confidence interval. This is what our prediction interval is for the new. Okay. So now take a look at that variance of y for x equal to x n plus 1 is sigma square. Now I am doing a new prediction, variance of y predict. If you want to make a predictions for that one, for new observations, you are making another prediction error with respect to the original yi. With respect to the original yi, this is our fitted line, and you are doing a prediction for the new data. So you are making another error with respect to the original one. So that is why an additional sigma square is added. After additional sigma square is added, if you write like this way, sigma square plus sigma square 1 over n plus x minus xi minus x bar square, and then sum of xi minus x bar square. And then if you take this sigma square out, then see 1 over n xi minus x bar square sum of xi minus x bar square. So take a look at the difference between. This is the prediction interval. This is the prediction interval. This is the standard deviation, like variance of the prediction interval, which is bigger compared to the confidence interval, that one. Okay. So now if you want to do the prediction interval, for new y new, what you will have to do, y new, and then plus minus t 1 minus alpha over 2 n minus 2 times standard deviations of y predict. Okay. So take a 10 minutes break. Okay. So I have shown you theoretically as well as practically why prediction interval is wider than the confidence interval. Okay. You understand, right? So I have talked a lot. Watch this video. I will upload these things and try to understand the basics. Understand? Basic questions. Why confidence interval is smaller than the prediction interval? What is the difference between R square and adjusted R square? Yes.
Example, we have to derive things like.
No mathematical derivations. All conceptual questions. Okay. So now after doing that, then I'm going to discuss R square and adjusted R square, and then I will discuss multiple linear regression. Okay. Take a 10 minutes break. Okay. Okay. I have started recording again. So far I have convinced you why prediction interval is wider than the confidence interval. Okay. Okay. So you have seen R code and the output as well as theory. So when you make a predictions for the new observations, for that new observation, another error you make. So that is why that when you're predicting with respect to the confidence interval, because you do not know the mean of the new yi, so you have to construct prediction interval with respect to the confidence interval for the original fitted data. And when you predict these things, you will make another error, and that is the variance of the another error. And this is the way theory work and theoretical justifications why prediction interval is wider than the confidence interval. Now, everyone know R square, right? R square and adjusted R square, right? So R square is known as the goodness of fit. Goodness of fit in regression. R square is known as the goodness of fit in regression. What does this mean? This R square is computed 1 minus error sum of square. Error sum of square. That means residual sum of square divided by total sum of square. Okay. So mathematically, if you ask me to write this, it should be 1 minus yi minus yi hat square. This is the error sum of square or residual sum of square, and this is the total sum of square yi minus y bar square. Okay. So what is the problem? What is the problem? Could you please shut down your computer? What is the problem of R square? So what is the problem of R square? What is the problem of R square? R square problem is that suppose this is most important thing. You need to understand this. Suppose this is your regression model. Yi equal to beta 0 plus beta 1 x 1. Okay. Plus ei. Now, suppose this is you are predicting weight from the height. Okay. Understand? You are predicting weight from the height. Okay. In this case, if you add a variable beta 0 plus beta 1 x1 plus beta 2 x2 plus ei. Okay. Suppose this xi is your suppose this xi is your blood pressure. Okay. So for the weight, I want to predict weight from the blood pressure. That does not make sense, right? Do you understand? Very irrelevant variable has been added. I can add another irrelevant variable for the weight. For example, what can I consider? For the weight, I can add another variable. So this is the first one. This is the second one. This is the third one. Yi equal to beta 0, beta 1 x1, beta 2 x2. And now I want to add beta 3 x3 plus ei. Suppose this x3 equal to my suppose income. Right? I am predicting weight from the income. Are you understanding? So the two variables that I have added, that is not make sense. That is the irrelevant variable, right? But if you add the irrelevant variable in your model, your R square value goes up. Okay? R square value when, let me write it, when irrelevant variable are added to the regression model, R square value goes up. R square value goes up means what? Goodness of fit is good, right? But that is a overfitting. That is called the model overfitting. Are you understanding? So in order to take into account adjusted R square is computed by using this formula 1 minus error sum of square divided by total sum of square divided by degrees of freedom and minus 2 and minus k minus and minus k just. I think this is n minus k, yeah. Let me quickly check the formula. Yeah, n minus k and minus 1, yep. That's the way. I have added these two things. Okay. So once you feed the model, regression model, and you get the output, you got the R square value equal to 0.82. Then you said 82% of the dependent variable is explained by the independent variables. And remaining 18% are due to the other factors or variable which are not included in the model. You know about this explanation, right? R square. But this R square value goes up when irrelevant variable are added to the model. In order to reduce that increase of the R square value, you need to adjust original R square value by their corresponding degrees of freedom. So that is why this is the error degrees of freedom n minus k, and that is the total sum of square degrees of freedom. Okay. Why n minus 2? Because there are two parameters, beta 0 and beta 1. Okay. I have added the materials there. Any questions before I move to the multiple linear regression? Yes.
How we do with the adjusted R square?
How? This is the adjusted R square formula. This is the R square formula. Okay. Error sum of square divided by n minus k. Total sum of square divided by n minus 2. So if you want me to write it again, R square formula is this. 1 minus error sum of square divided by total sum of square, and R square adjusted 1 minus error sum of square divided by n minus k, total sum of square divided by n minus 1 n minus 2. Minus 2, minus 1, and minus 1, and minus 1. So if I ask you what is the difference between R square and adjusted R square, you have to explain these things. And you know how to explain the betas, right? Beta 0 equal to tan. How can you explain that? So this means average value of dependent variable equal to tan when x's are 0. Okay. And what is the explanation of beta 1 equal to 3? 1 unit change in x1 on an average 3 unit increase in y, right? You know this simple things. Okay. Now I want to do multiple linear regression model, and then if I have some time, I will go over the homework. Ready? If you think that I am not covering like lot of materials, but think about this. You have learned simulation, text mining, and web analytics, right? So another professor like Dr. Kessingman, he is covering something else. Maybe I cannot cover all of what he is covering, okay? Because I am at least 3 weeks behind from him because of simulation, text analysis, analytics, as well as web analytics, right? So you must write in your resume that you have done text mining and web analytics homework. Understand, right? In addition to data analysis, you also know now text analysis. Okay. Now I want to do this type of modeling. Y I equal to beta 0, beta 1, x 1I, beta 2, x 2I, and beta k, x ki plus ei. Now if you plug I takes value 1, 2 up to n. Okay. Take a look. If I put here y1 equal to beta 0 plus beta 1 x11, beta 2 x21, beta k x k1 plus e1. Now I want to do y2 beta 0 plus beta 1 x 1 2 plus beta 2 x 2 2 plus beta k x k2 plus e2. Then if I continue these things, yn equal to beta 0 plus beta 1 x 1n plus beta 2 x 2n plus beta k x kn plus en. Right? If I plug this, so this could be written in the matrix format y1, y2, yn. This could be written in the matrix form y1, y2, then x 1 1 x 1 2 x 1n x 2 1 x 2 2 x 2n, and then I can write x k1 x k2 x kn. Okay, then I can write here beta 1 beta 2 sorry beta 0 beta 1, and then I can write here beta k, and then plus I can write here e1 e2 en. Right? And this could be written in the matrix notation y equal to x beta plus e. Okay. From there I can write e equal to y minus x beta. Okay. Now I can write e prime e equal to y minus x beta, and then y minus x beta. This is error sum of square. This is error sum of squares. Now error sum of a square could be written f y prime y prime x beta, beta prime x prime y, beta prime x prime x beta. If I multiply these things, I am get this. Now I differentiate these things with respect to beta. Now these two things are the same. Do you know why? Take a look at that. 2 1 4 1 0 1, and then 1 2. If I multiply these with that, then what I get? 8. Right? If I multiply these with that, then what I get? 3. If I multiply this by that, I got this. If I multiply this by that, I will get this. This is the matrix multiplications. Then I have 1 2. Then if I multiply this and that, I have 8 14. So I got one number. One number in matrix notation is known as the scalar. A scalar. Okay. It is called the scalar. Okay. One number. So this is a row vector. This is a 2 by 2 matrix, and this is a column vector. If you multiply these things, it will give you a one number. In matrix multiplication, if you multiply 2, 3 matrices and get one number, that is called the scalar. Okay. So this and that are the scalar. If you multiply these things, whatever you will get, exactly same thing you will get if you multiply these things. Okay. These are two scalar. So then this could be written as y prime y to beta prime x prime y plus beta prime x beta. So if you add these two things, you will get this one. Now, if you differentiate these things, this will become 0 because there is no beta. I am differentiating with respect to beta. And there is a beta is in there. So according to the matrix multiplication operation will work in here. So it will be x prime y, and then it will be 2 x prime x beta equal to 0. If you differentiate these things according to the matrix differentiations, vector calculus. According to the vector calculus, if you differentiate these things, you will end up with that. So from there, you will have x prime y equal to x prime x beta. Okay. So now if you multiply both sides by x prime x inverse x prime y, x prime x inverse x prime x beta, multiply both sides by this quantity, then this and that cancelled out. This and that. A inverse A equal to just identity matrix. Just it's gone. Okay. So as it is gone, so I have beta hat equal to x prime x inverse x prime y. So for the multiple linear regression model, our beta estimate is this: x prime x inverse x prime y. Okay. Clear, right? Then I am going to compute the variance. After computing variance, then I will go to the homework. So I want to compute the variance of B hat. Could be computed variance of x prime x inverse x prime y. This is the variance. Okay, as I said, you x's are fixed. That's gone. So we had beta hat equal to x prime x inverse x prime y. Now I want to estimate variance of beta hat, which is equal to variance of x prime x inverse x prime y. Okay. Now, in matrix notation, if you want to find the square, you have to do these things. So for example, you want to find in the matrix notation square of a matrix A, then you should write it A and A transpose like this, or you have to write it A transpose or A. Okay. So similarly, this is our constant part. I say to you, in simple and multiple linear regressions, x's are fixed. You understand, right? I draw a very beautiful graph and took a height 5, and corresponding to that height 5, there is a different weight, and then weight has a distribution. I draw that picture, right? Okay. So now similarly in this case, if I want to write it, x prime x inverse x prime variance of y, then x prime x inverse x prime, and it has a prime over there. Okay, this is the way you have to write this is the notation of writing variance formula or a square term in matrix notation. Okay, so now if you want to do this minus that quantity equal to sigma square, that is what I know, and here x and then x prime x inverse. This is what I have. As this is a constant, we can take out in later part x prime x inverse x prime x x prime x inverse times sigma square. These things and that things are inverse, so they cancelled out. So we have x prime x inverse sigma square. Okay, clear, right? So I have finished theoretical discussions for simple and multiple linear regression model completely, and I have also given you the interpretations and meaning of what is residual, what is error, what are the assumptions of the linear regression model, and what are how the prediction interval is different from the confidence interval, right? What is the difference between error and residuals? If you pay attention, you understand this. How to explain R square and adjusted R square, you know this. So what is the difference between confidence interval and prediction interval? Prediction interval is you are predicting for a new data. That data is not coming from the original data. That new data mean you do not know. So you have to construct prediction interval from the confidence interval. So that is why you are making a one more error. When you are predicting on a new data, you are making one more error. So that is why prediction interval is bigger than the confidence interval. Then I discussed how to explain R square and adjusted R square. I also explained how to explain the parameter beta 0 and beta 1. Okay, for multiple linear regression model, this is important thing. Take a look at that. Suppose you have yi equal to 10 plus 13 x1 plus 3 x2. This is what you have model. Okay, this is the multiple linear regression model with two variable x1 and x2. Let me add another two, 7 x3 and then 4 x4. Understand? So my question is, how can you explain these three? Beta 3 equal to 3. How can you explain this for the multiple linear regression model? Can any one of you tell me? 1 unit change in x2 on an average 3 unit increase in y, keeping other variable fixed. Okay, you partially explain these things, but you cannot explain the entire model. Are you understanding? That is why multiple linear regression model, each coefficient is also called partial regression coefficients. You partially explain these things. You cannot like 1 unit change in x1, another 1 unit change in x2, another 1 unit change in x3, another 1 unit in change in x4, then on an average 13 unit increase in y, 3 unit increase in x, y, and 7 unit decrease in. You cannot explain like that way. Even though it is multiple linear regression model, you cannot explain or interpret all parameter estimates simultaneously. Are you understanding? Partially. Okay. I think I gave you all the explanations and everything. Let me open the homeworks. So next class I will do logistic regression and probit regressions, but I will give you different problem. Who else are taking my class? 500? Who else is taking 500? You are taking 500 also, right? So both of you will do support vector machine homework. Next class I'm going to do. No, well, the reason I already gave them an advantage because they have done cluster homework, cluster analysis homework in 480. I wanted to give them new homework. They said that no, that's enough. So give us one exercise. Okay. So they are doing cluster analysis homework again in 500, right? 500, yeah. No, 500 there is a cluster analysis homework. You already did it in 480. So you are doing it. But here, there you are going to do logic and probit. But here you have to do not logic and probit. Then you are getting good grade for the reading the same material. And down the road, 3, 4, 5 years later, you said, Dr. Chaudhary is a nice guy. He gave us good, but we did not learn anything. We pay the tuition, but he teaches the same thing. I don't want to blame me like that, right? Looks like she's super happy. So I will give you support vector machine homework, okay? Support vector machine. Support vector machine is a classification. This is completely developed by the computer science people. There is a what it called, like the linear programming approach they have used. Okay, now let me open the homework. Here, you must use Python to solve this homework. I have provided RCode. You must provide me Python script and a report, either in Word or PDF file. Write one sentence for each of the 25 problem. How many problem? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of these, if you count, there is 25 problem. Okay. Okay. For example, first one, use D3.CSV data to fit a simple regression model by selecting a dependent and independent variable. Do not use SBP and DBP, which I already used. Okay. You use another one. So then first one, what will be your answer? I read the D3 data and I use triglyceride as my dependent variable and weight as my independent variable. That will be the answer. Okay. Give rationale for selection of your independent and dependent variable. You can say that the biomedical research says that we can predict blood pressure or we can predict triglyceride from age. So that is why I put triglyceride. I'm telling you the answer. Triglyceride is dependent variable and age as the independent variable, because when age goes up, triglyceride went up. Okay. Or cholesterol as a dependent variable and age as independent variable. When age went up, cholesterol level goes up, right? Report whether your intercept and slope coefficient are significant or not. How can you say that? By looking at the p-value, right? You can say that by looking at the p-value, we see that intercept and slope coefficients are significant, or they are not significant, or one of them significant, other is not significant. Are you understanding how to write the report? I will grade this very strictly. Okay. When I start grading, I have to take out my things and I have to sometimes put water in my eyes. Okay. Because at the end of the semester, you will evaluate me how much material I have given you, whether I tried my best to give you good education or not, right? Because you are grown up, you are matured, right? Right? Yes. Okay. Report the confidence interval of the estimate of the regression coefficient, right? Confidence interval. Right? What percentage of dependent variable is explained by the independent variable? How can you say that? By looking at the R square value. Show a scatter plot together with the fitted line. Okay. Show a scatter plot together with the produce a prediction interval. See, now I say prediction interval for your fitted regression line. So you can say that, well, I have created my prediction interval as follows. Okay. How can you explain changes in dependent variable in terms of changes in independent variable? 1 unit change in X on an average slope unit change in Y, right? Side by side, show the box plot and histogram of the residual. Put smooth curve over the histogram. Over the histogram, put the smooth curve. Okay. Does the histogram look like symmetric? Check the Shapiro-Wilk test for normality for the residual. Residuals are normally distributed. Check whether it is normally distributed or not by using Shapiro-Wilk test. If Shapiro-Wilk test p value is less than 0.5, which means non-normality, can you suggest any method to make this residual normal? Just write 1 or 2 sentences. Hints, transformation. What are the other transformations you can write? If someone write the correct transformations, I will give him or her a secret credit. Only me and God and the guy knows. If she write the correct transformations, only she will know, I know, and God knows. You understand what I said? What did I say? If Shapiro will test p value less than 0.5, on what? On residual. On residual, right? So that means residual is not normally distributed. How can you make a residual normal? Okay. One is log transformations, but there is another strong transformation. Find it. I'll read your report thoroughly. I want Python script as well as report. Okay. Please don't cheat and don't destroy your life. If I catch you, I will not only give you F, I will also insult you. No, don't laugh. Seriously. Okay. So similarly for the multiple linear regression. Okay. Use D1 CSV data to dependent independent variable, provide rationale for why I said D1, it should be D3. Okay, it should be D3. It's typo. And then you can hear I said QQ plot. Okay, QQ plot means what? Quantile plot. Theoretical quantile, sample quantile. If they are normal, then there will be a very beautiful diagonal line. Okay. QQ plot, quantile plot. Within -3 to +3 in standard normal distributions, more than 99.7% of the value false. Okay. So theoretical quantile is in the x-axis and the sample quantile is in the y-axis. In that way, you can get the results. So next class, I will discuss logistic regression and probit regressions. Okay. And after that, I will discuss maybe what it called. It is known as the association rule and regression and decision trees and maybe neural network. Okay. Any question? Comment, problem? Personal problem that you do not want to share? Okay, I'm going to stop in here. Okay. So some of you might need to catch the bus which left at 8:20 last bus. So I'm going to stop in here. See you.